is Unit 12, Lesson 2, completing the square to solve and graph a quadratic. After this lesson, you will be able to complete the square to find the roots of a quadratic, graph a quadratic by finding the vertex and roots and by completing the square. Here we go. So let's remind ourselves, we're used to seeing quadratics in standard form, ax squared plus bx plus c. We're making sure they're in vertex form, x minus h squared plus k. If we remember the steps from yesterday, completing the square, we set the quadratic equal to 0, move the constant to the right side, divide second term by 2, square the result, add number from step 2 to both sides of the equation, simplify both sides, move the constant back over to the left side. That will give you from standard form to vertex form. Now, on this one, example 1, solve for the x values of the quadratic. If you remember, x values of the quadratic are the same thing as the roots and zeros, all the same name. So, we know we're solving for x. In order to solve for x, I have to undo anything that's on the same side as x. Now remember, this is reverse order of operations. So instead of starting inside the parentheses, I'm actually going to start on the outside of the parentheses with the constant. In order to get that 9 to the other side, I need to add 9. That will give me parentheses x plus 2 squared equals 9. Now, I, again, am solving for x, but I can't touch x while it's inside a parenthesis. So I need to get rid of what's on the outside of the parenthesis. On the outside, we have a square. Well, how do you undo a square? What is the inverse operation? Square root. So when I square root x plus 2 squared, the squared cancels, and I'm left with x plus 2. But in the land of equation, what I do to one side, I also have to do to the other side. Now remember, when you take the square root of 9, yes, you get 3. But actually, you get the plus and the minus 3. Because 3 times 3 gives me 9, but also negative 3 times negative 3 gives me 9. So when going backwards and taking the square root of 9, I get plus or minus 3. Now we're used to seeing two roots where they cross the x-axis. So I need to get two equations. So I'm going to write x plus 2 equals positive 3. For my second equation, I'm going to write x plus 2 equals, but this time I'm going to do negative 3. Solving both equations, I'm going to subtract 2. My first root is x equals positive 1. Over on this side, I'm going to subtract 2, and I'm going to get my second root, my second x value, which x equals negative 5. So just to recap, we moved the constant, we square rooted both sides, and then we solved two equations. And that's how we find our x values from vertex form. Pause the video now as you try example 2. Press play to go over your answer. Use your problem from example 1 to help guide you. So we're going to go ahead and add 16 to both sides. X plus 7 squared equals 16. We're going to take the square root of both sides because it will cancel my square and break x plus 7 out of the parentheses. But I remember when I take the square root, I get the positive and negative. Square root of 16 is 4. Set up two equations. X plus 7 equals positive 4. X plus 7 equals negative 4. I'm going to go ahead and solve both of them by subtracting 7. I get my first x is x equals negative 3. On the second one, I get x equals negative 11. And there's your answer for example 2. Pause the video now as you try example 3. You really should be getting the process by now. Do your best. I believe in you. So we go ahead and add 4 to both sides. X plus 3 squared equals 4. We take the square root of both sides. Oops, sorry about that. And we get x plus 3 outside of the parentheses equals the positive and negative of 2. Don't forget to take the square root. That gives us two equations. X plus 3 equals positive 2. And x plus 3 equals negative 2. We subtract 3. X equals negative 1 for our first value. Subtract 3. X equals negative 5 for our second value. There we have our answer for example 3. Pause the video now. Just kidding. Don't pause. Unpause. People, we're going to take a look at example 4. It says